Namaskar from our channel, The Consultant's View. Mizoram, it is one of the beautiful states in India I had ever been. I am fortunate to get an opportunity to work in the state, experienced a fabulous hilly landscape. The project was on septage management in the cities of Aizawl, the state capital, and Lumle. It started in the year 2013-14. I have observed a different type of settlement in this state. Normally, a hilly town gets developed along the slope of the hills. In this case, the tendency is to have more settlement concentrated along the ridge of the hill or the ridge areas of the hills, unless there is a scarcity of land on the ridges. Though this settlement nature poses more challenges in water supply system in respect to operation, but it is advantageous to sanitation system, mainly in respect to sewerage network planning irrespective of the final treatment or disposal point of location. The sanitation system which existed at that point of time was latrine with septic tank. The soil nature being predominantly rocky, soak pit was not a very successful component functionally. The project aimed to introduce best practices for septage management in the state of Mizoram. It focused on organizing the existing sanitation system with a sustainable septage management backed by engineering logics. Building a new sewerage system was beyond the scope of this study. Different septic tank sizes with user numbers, outlet levels, its location within the premises were thoroughly investigated and analyzed. Septic tank standardization was formulated and a nomenclature on septic tank designation was established. The basis of designating septic tanks was based on some parameters: user's number, size or volume of the tank, location which dictates septage withdrawal pipe length, cleaning mechanism, location of the premises with respect to hills or valleys, accessibility of roads, etc. For example, if a septic tank is designated by the nomenclature say S5B2, then S symbolizes septic tank, 5 is the user's number, B designates space available within the plot, and 2 indicates whether it is on the front or back side of the premises. There was a long-term vision of the project authority in respect to cleaning activity, keeping in mind that in future cleaning activity can be through online services where each house or premises will be connected through MIS and integrated with GIS. The approach was basically to introduce a smart cleaning mechanism, though 10 years back this word smart was not that popular. If a owner puts an online request through mobile apps for septic tank cleaning, all details will automatically be known to the operator. Accordingly, the operator will get an idea on the size of the tank to decide capacity of truck, position of the tank to decide length of suction pipe, and nature of route to decide the route pattern, and available space of the truck and emptier to park during the cleaning operation. The major components of septage management can be broadly divided in 3 activities: collection system of septage, transportation to treatment location or disposal site, and treatment process. Treatment was proposed as a traditional method. The site was proposed to be developed from technical point of view, keeping in mind the factors of earthwork balancing, natural gradient, nearest natural stream, access road, power availability, etc. Operation sequencing was also developed. It was predominantly a natural process which was sustainable from social, economic, and most importantly, environmental point of view. A catchy name was given Green Mizo, as it resembled environmental friendly management system. Collection of septage was a challenge. In some pockets, the road being narrow, it was not prudent to go for higher capacity emptier, even if the septic tank size was large. The ground situation required multiple trips for single cleaning activity. These criticalities were considered during planning stage. In some cases, septic tanks were at a much lower elevation than the road elevation. The pipes and the pumps were proposed to be customized. All these critical site situations were thoroughly analyzed and septic tank nomenclature was formulated accordingly. The biggest challenge was to transport the septage from collection point to the treatment unit. Let me discuss the challenges in detail. The area of the city was divided as zones for septage management. Each zone will have one septage treatment system. The septage transportation route was optimized within the respective zone. Zoning was required not only to optimize the route, but it also facilitated in institutional framing. First challenge was to selection of route from each locality to the designated treatment site. The road width being narrow, most of the roads within the main city center and its vicinity were one-way traffic. Hence, an intensive route planning was done with time slots. Here, optimization of route was linked with fuel consumption. Optimizing fuel consumption is one of the main parameters. It involves a combination of effective driving techniques, proper vehicle maintenance, and thoughtful planning. The deciding factor for obtaining green economic speed where fuel consumption will be least depends on longitudinal slope, nature of the road, traffic condition, maintaining momentum, and most importantly, driving techniques. We took consultation of a subject expert on this. Though ideally a speed of 50 to 80 km per hour is an economic speed, but in that topography, mainly near city center, achieving more than 20 km per hour during daytime was a blessing. So, the subject expert considered the ground situation and analyzed the optimum route accordingly. Driving efficiency in hilly roads increases with minimum usage of engine braking, avoid aggressive driving, staying in mid-range gear as far as possible, leverage vehicle momentum and inertia, etc. Good drivers always use predictive driving. Total operating cost depends on initial capital cost, its life, interest rate, number of trips, total mileage per trip plus haulage, maintenance cost per trip. Equivalent annual cost versus output in kilowatt was also derived for different cases. Accordingly, optimum route was finalized. There is another critical point. In each locality, road widths were measured. Parking point of the MTA was designated. It was not possible to park the vehicle right in front of the premises where narrow road width existed. In such cases, long suction pipe was evident to reach out to the septic tank point. As per my experience, we, the consultant, give more effort on selecting treatment methods and investigating septic tank details. But to achieve a comprehensive, sustainable solution for septage management in hilly towns, route planning and its optimization is most important activity. Hope I am able to share my perspective on this topic, assuming that the proposed solution will be implemented on ground and not to showcase as a document for project funding approval. Hope you enjoyed this technical session. Thanks for watching. Namaskar.